Okay, hi everyone. So if you spent any time in economics or microeconomics, you've probably seen this graph before. This is the price versus quantity graph. It's pretty common. You've probably seen it elsewhere as well in news and in publications and any lessons you might have taken on this topic. And this is a pretty important graph, and it's also it's a graph that you learned pretty early on. And this graph actually eluded me for a while. Like I couldn't really get my mind around it for a while. But I have an explanation that I believe will help you get a very simple base level intuitive understanding of this. So this is going to be very intuitive in terms of an understanding. It's not going to be a rigorous understanding at all. This will get you started very well, I believe. So let's get to it. So to start off, let's make a graph that's going to help us understand this bigger graph. So kind of a subgraph. So here's our graph right there. And what this graph is going to do is it's basically going to plot the amount or the price I can charge for strawberries. Let's say I'm a strawberry seller, right? The price I can charge for strawberries based on how much people like my strawberries. So let's say how much people like my strawberries is the amount to which people like my strawberries. So let's name it A, just for a variable name that doesn't conflict with anything else. And then that's going to affect the price. And okay, let's just think of this intuitively, right? So as people like my strawberries more, I can basically charge more. So just from your own intuitive observations, you might have seen if people like something a lot, you can charge more for it. So it's going to be up there. But if people don't like my strawberries, of course, I cannot charge very much. So it's going to be something like that. And then the graph is going to be like that. Just intuitively speaking, that makes sense. And let's make another graph. So a secondary graph we can make is basically going to flip the variable names around. So we're going to have price on this side, and then the amount people want my strawberries here. And once again, let's think intuitively here. So if something's costing very much, that's going to be correlated with a lower degree that people want it. So there's going to be a point here. But if something's very cheap, people are more likely to like it, right? Like, would you buy a very expensive car that's the same? Like, if two cars are the same, obviously you're going to want a cheaper car, the cheaper option. So it's going to be something like that. So if my strawberries are very expensive, less people are going to want it. And okay, this assumption here is a little bit problematic in a lot of cases. So this is the assumption that's probably the weakest in my intuitive understanding. So don't hang a lot of your explanations or understandings of economics around this graph. So this is just to get you started. So in this case, let's have some labels that are going to be important later on. So for this one, you can think of this as a graph that's good for me, right? As a strawberry seller, this graph, it basically tells me how much I can charge for strawberries based on the demand from society, basically. So this graph will help inform me, the supplier. So let's call this supply graph. And this graph, it basically talks about the demand. So here is the demand as dependent on, or the quantity demanded as dependent on the price. And so let's call this the demand graph, because it's basically what it's showing. So now let's put these two graphs together, and you can already see where this is going. So the first step we have to do to put these two graphs together is to flip this graph around, right? We see what we want to end up is a graph with the axes like what's up here. So we want a graph with the amount people wanted on the x-axis and the price I can charge, or the price on the y-axis. And in order to do that, we have to reflect this. So hopefully remember the rules of reflection. If you're reflecting the axes, that's reflecting around the x equals y axis, and that's basically how it works. So if you remember from like algebra 1, basically, if you have like the graph x squared, to reflect that, you reflect it around its axis. So it's going to be square root of x. So something like that. And basically, as you can see, this graph basically stays the same. So what was a negative correlation before stays a negative correlation, even with the inverse of the graph. So let's put those two graphs together. So we have amount people like it here, and then the price here. And once again, we can label this one going up is supply, this one going down is demand. And we have this graph up here. We just have different variable names. So to start off, we have P, which is the price, is this. And down here, we have quantity. Okay, so a couple things to take note of here. First of all, limitations. Basically, the biggest limitation is this one right here. This assumption from this graph here is a bit complex. So basically, we have demand and then quantity demanded. So demand is basically like a function. Quantity demanded, you can think of it as how much people like strawberries at a specific price. So technically the way this is drawn is like, it's incorrect, but it does lend itself well to a good intuitive understanding of this graph. Meaning that quantity demanded is dependent on a price. So you can think of like something over here, like a specific part of this graph as quantity demanded dependent on the price. And so we basically translate that graph over here as a demand. So one other thing I want to mention is that the biggest part of this graph that's important to know is that this is a positive slope for supply and this is a negative slope for demand. So these don't necessarily have to stay in the same place. Like these graphs can move around. We can have graphs that are shifted. And this happens if something is like better or worse. So like if people like somehow like start liking strawberries more, then these graphs move. They move. And so as these graphs move, these positions are not necessarily fixed. So for example, the origin is not always going to be where the supply graph intersects. And something else to take note of is these don't have to be perfect lines. So we can have like curves. So we can have curved things, and you'll see that in many cases as well. But once again, you'll see that this is still kind of a positive correlation, right? The average, so we were to calculate the average slope going through that, it is positive still. So that's one thing to take note of. Also, one term to take note of is this point where it intersects, in my analogy, remains the point that is intersect on the actual graph, which is the equilibrium point. So it holds up to those kind of things. But of course, once you look at more rigorous things, this analogy may not be 100% accurate after that. So hopefully you got a good intuitive understanding of this. And it's an interesting topic, albeit for me at least, it's a bit difficult. But definitely I encourage y'all to explore this, challenge this, definitely put any challenges you have to this explanation in the comment section below. It's going to help everyone, me and any other watchers that have, oh wait, what if this, what if that? It's definitely going to help those kind of people. So definitely put any questions or concerns you have with this there. Even if you think this is completely wrong, put that in the comment section below. I'll be happy to hear it. So yeah, thanks for watching. See you later.